Hello, my name is Ricardo Marin, and I'm going to be doing my homework 2 video presentation lecture thing in t-test and SPSS. So this is kind of how it's going to go throughout the video. I'm going to have, for the first few slides, I'm going to do face cam and then probably turn it off to reduce the file size like you recommended. But we're also going to have a kind of structure for this lesson. So for this lecture structure, I'm first going to explain what a t-test is. So I'm going to be going into how to perform a t-test, kind of what it is, not too in-depth or anything like that, and some examples for each of the individual t-tests that we're going to do. And then I'm then going to go into how to use SPSS. Again, not a super in-depth thing, just to kind of get you familiarized with what SPSS is and how to kind of use it. But besides that, it's just going to be like a very brief overview before we go into using t-tests and SPSS. And we're going to actually be doing a demonstration of each of the individual t-tests that you can do. So the one sample, the independent, and unpaired, and then the paired t-tests. Okay, so first we're going to go into our t-test explanation. So a t-test overview. A t-test is used in statistics mainly to find the difference between the means in two different data sets. Or depending on which t-test that you're doing, maybe it's just one data set and a accepted mean, but again, we'll go into that later. This can come in various forms, such as the independent, the two sample, or the paired test. But first, to begin, I'll just describe the steps to perform a general t-test. This is kind of just like generalizing what each of the t-tests can do. And then we'll describe the difference between the different types of tests that you may want to perform. So to begin, you want 1 to 2 individual data sets depending on the test that you're doing and construct a null and alternative hypothesis around them. So here. Step 1 is constructing the hypothesis. A null hypothesis will generally state that there is no difference between the means when the t-test is done. So what this kind of means is that, let's say you have a, what's it called? A research question that you're trying to find out the answers to. The null hypothesis will generally say that there is no difference between, let's say, the accepted mean of a population and the sample population that you're using. An alternative hypothesis, in other words, will state that there is a significant difference between the means, meaning that there is a significant difference between the sample population and the accepted mean or a different sample population. Okay. So now going on, let's see. So for an example of this kind of inaction, we can say that we're trying to see if there's a difference between a group of people's weights before and after they participate in a weight loss program, or a diet, I mean, before and after they participate in a diet. The null hypothesis will state that there is no significant difference between the weight of the participants before and after the diet, and the alternative hypothesis will state that there is a significant difference between the weight of the participants before and after the diet. So once we actually run our t-test and find out, I guess the p-value and test it against our significance level, we'll be able to either reject the null hypothesis, which is essentially going with the alternative hypothesis, or we'll be able to accept the null hypothesis, which is stating that there is no difference between the weights of the participants before and after the diet. Alrighty. So now we can get into the significance level. So significance levels help us to determine the probability that our results are due to random chance, or if there's a statistical improbability that the test results are an outlier in determining whether or not to reject or accept the null hypothesis. So it's kind of just the threshold for what we want. And generally in statistics, we set this value to 0.05 or 5% that the, what's it called? That the test we just ran is an outlier. The p-value is later then used to compare with the significance level to see if we reject or accept the null hypothesis. So essentially, how I understood this is that what's it called? The significance level being set to 0.05 or 5% is the like number of times, like the so when you run the t-test, the 5% signifies that give me a second, sorry. I'm like trying to remember everything here. The 5% is usually the chance that what we just did in the t-test with the data set and the groups is like a outlier, a statistical anomaly. So 5% of the time it will, so let's say that in our previous example with the diet program, um, we do get a, what's it called? A 0.05 as our significant or as our p-value. Then that will mean that about 1 in 20 times that, what's it called? This result in general will be an outlier kind of. That's kind of how I understood it, and I am kind of explaining this poorly, but I hope that kind of made sense in a way. So now that we are done with our significance level, we are going to be going on to performing the t-test using software. And this is probably where I'm going to turn the camera off so that we can get more space here. Give me a second. There we go. Okay, so performing the t-test, performing the test using software. Um, so once we have this ready, we can perform our t-test using whatever method we want, whether it's SPSS or calculating it by hand. From this test, we determine the t-statistic, the degrees of freedom, critical values, confidence levels, all this neat stuff that you can use in statistics. Um, so actually explaining what it is, the t-statistic is the difference of the two means of the data sets over the variance of the normally distributed data sets. The degrees of freedom are the number of values that can vary in the data set before some type of constraint must be enforced. So the number of these independent values is used to both find the p-value and the critical value. But for our purposes today, we'll only be using the p-value in order to kind of find whether or not we reject the null hypothesis. But we could also get into the critical value if we wanted to. So depending on depending on the software or method that you use, you can use the t-statistic and the degrees of freedom to find the p-value to determine whether we want to reject or accept the null hypothesis. So now that we understand how to perform a basic t-test, we can find the difference between the three major types of t-tests. Okay. So first we have our one sample t-test, which is used when we have a previously accepted mean and we want to compare a sample population to the accepted mean. So, for example, let's assume that we are testing for whether a company's employees work the national average standard of work weeks. Our sample population would be the mean of the company's average employee work week tested against the national average, which would presumably be around 40 hours or so. Once tested, we can determine whether or not the p-value supports that the employees do or do not work the average work week. So let's say that the average comes out to be like 45 or something for the average employees in this company. The p-value would probably show that would probably be about above 0.05 and show that there is a distinct difference in the means of the accepted value and the and the sample population that we had. So for now, we can move on to our next sample t-test. So next we have the independent or unpaired t-test. This is used when we want to test two independent groups and determine if there is a significant difference between their means or not. Okay. So, for example, in this one, let's assume that we are testing for the average distance someone can throw a baseball based on genders. We would have two independent groups, being the males and females, and test whether there's a significant difference between their throws. So, yeah, this is kind of testing one independent group against another, and seeing if their distances vary in any way. And again, if they do vary, the p-value will reflect that, and then we can reject or accept the null hypothesis based on that. So here, actually, let me turn this down. Okay. Next, we have our paired t-test. This is used to test the same type of person twice in order to determine whether a factor contributed to a change in the mean. Okay, so for this, we can go back to our earlier example of weight loss based on a diet. So a researcher wants to find if there is a significant correlation between a diet and the participants' weights before and after the diet. So here, the two groups that we would be testing against are essentially the same people, but a factor is put in place to see if it affected the mean in any way. So here we have the weight before the diet, then the diet happens, and then the weight after the diet. So essentially what we're trying to find is if the diet had any effect on the weight whatsoever, and reflect it using one of the t-tests. So now that we kind of understand how each of the t-tests work, what a general t-test is, and how to perform it, we can kind of get into SPSS itself in order to kind of familiarize ourselves with the program just a little bit. So SPSS is one of the biggest statistical analysis software that is touted for its ease of use and simple interface. This software does not require any programming whatsoever and is simply used to insert data into the software and perform some pre-set tests. It's a lot less flexible than some other, let's say, programming languages, but what it is very easy to use for most people. So like if you're not a programmer or anything like that, I know some non-programming statistics class mostly use SPSS. Because it just is really easy to use and really easy to understand. Kind of looks like an Excel sheet. It is kind of just easy to pick up, and most people can just kind of get into it if you know what you're doing. So there are two main parts to the interface of SPSS. One is the data view. And the data view is kind of where we see the information that our data set is based on, and where each rows represent each of the individual people or participants of a sample size, and the columns represent the variables with each person or group. So here we can see that each of these numbers right here would kind of represent one individual person. Each of these variables up here would correspond to each of the people's, like, let's say their weight, their height, their age, their just stuff like that, gender, all that other stuff associated with the people. So row represents person, column represents an attribute related to that person. So that is the data view. This is where we're going to see most of our information that you kind of see in a data set in general. So now we're going to get into the variable view. The variable view is an interface that allows you to define the columns in the data view. So actually, let's go back right here. Each of these variables right here, let's say the age, height, and weight and stuff like that, are going to have each individual kind of properties about them. And you can define them using this variable view. So you have the name variable, which is what will be displayed up here. So instead of it saying var here, it would be age, weight, height, group, all that stuff. The type of variable that it is, so whether it is a numeric variable, a string variable, a date, like there could be a lot, like a few different options that you can choose from. Um, you can do the width, which is the characters, what's it called? I'm pretty sure that this is kind of just the amount of numbers that you can set for like number variables and stuff like that. Like it's used for stuff like that. Decimals, so the number of decimal places that you can use for a number variable. So just if you need decimals, how many places they can go. Um, what's it called? You can go for the label, um, which how do I explain this? It kind of just helps in knowing what the variable represents in a way, I guess, is how I would define it. So then you can go for values, uh, which kind of, how would I say this? Let's say that you have a numeric string in the type. Instead of like it being like M or F or something for like male or female, you can associate a number for each of these things that you can use later on when defining groups and stuff like that. Um, you can also do what's it called? Missing values. Uh, I'm gonna be honest, I don't know what a lot of these afterward do. Um, I'm pretty sure most of these are just kind of how the data is formatted itself in the data view. So like alignment just kind of shows how it would be aligned in the uh, in the data view itself and all that stuff, or in yeah, how it would be aligned in the data view. So now going on to importing CSV data. So importing data is very important in SPSS as it kind of allows you to use any kind of database that you want and just easily put it into SPSS itself. So here you can just, oh, give me a second. Okay, sorry about that. Had a little bit of an interruption, but the CSV data can easily be imported into SPSS. All you have to do is go into File, go into Import Data, and then CSV data, and from there you can just choose your file that you want to import. Okay, so now that we have kind of gotten through most of what I wanted to show you with SPSS before we started our test. I also want to state that SPSS itself is able to make a range of. I know I said earlier it's kind of limited in the amount of tests that it can use, but it can do a ton of tests, preset tests from chi-squared test to ANOVA to regression. Um, but for our purposes, we can use every type of t-test in this software. So now we're going to be going into how to do each of these individual tests in SPSS itself. So, oh, sorry, I messed up the labeling here. It was supposed to say just general SPSS, not a one sample test. That is my fault. I will fix that once I submit it, but first, you want to identify the group that you want to test, which just kind of means like in your data set, you'll have a ton of different columns. You'll want to identify which group you want to test or groups if you're doing a independent test and stuff like that. You want to find the mean that you want to test the group against. You'll want to insert the information into the software, clean up any of the data that you may need to, run the test, and evaluate the results. So this is something that I didn't talk about really, but in SPSS, it's actually pretty easy to clean up data. You can kind of disable group, like you don't even have to delete groups in the what's it called, data set itself, you can just enable and disable certain types of groups and run the test without using them. So that is very helpful if you don't have any if you have data that's not cleaned up yet. So first, what we're going to be getting into, and sorry, I keep doing things out of order here, but we're going to be using two different data sets in this example. So the first data set is going to be a like a school, basically like a grades data test based on students. So there's a bunch of different variables, but what we're going to be getting into is the GPA and tutoring aspects of it. That's going to be the data set that we use for the one sample and the independent t-test. And for the for the paired t-test, we're going to be using a weight loss data set in order to check the weight before and after a diet. So like the example that we used earlier. So now, performing a one sample t-test in SPSS. So for this one, like I said earlier, we are going to perform this test with the GPA sample data. All the data is already cleaned and we're ready to go, so all we have to do is run the test itself. So as we can see here in the data view, we have our GPA data set, or our GPA variable or column here. So this is going to be the data that we use to test against an accepted mean, and that accepted mean we'll get into in a bit. But this is the data that we're going to use. So first, what you're going to want to do is click on the Analyze tab, which has most of the tests that you can perform for statistical analysis. Then you can choose the one sample t-test. And before we go on further, I got a little confused the first time I was using this because I went to power analysis and did the one sample t-test there. And it was not working as like the tutorials and everything that I had seen had done it. So just beware that if you are going to do a t-test or any other type of statistical analysis, honestly, make sure that you go to the correct one. So here it's in the compare means and proportions tab, not in the power analysis tab. So this is the screen that you should see once you kind of click on the tab itself. You have all your variables and all your columns on the left here. So you can do pretty much any test, a test on any of these kind of variables that you have here. I'm pretty sure test variables you can only do numeric columns with though. So luckily our GPA is a numeric column. So you can just kind of click on that. And then when you click on that, you can press this arrow right here to select the GPA field and bring it to the test variables field. And then once you have that, you want to enter the test value, which is the accepted mean that you want to test the data against. So for this, I did 3.0 as the test value or the accepted mean. This is just kind of a general accepted GPA for high school students that I found on a couple of websites. It's not anything too specific or anything like that, but it's kind of a general accepted mean. So once we do that, we submit the data to perform the test itself. And what we get here is what's it called? We'll get a pop-out window that has the results of our tests in them. So we have our t-statistic is negative 58.456, which is kind of the, what's it called? The difference of the mean over the variance, like we said earlier. The degrees of freedom is 2,391. So you can tell that we have a pretty big data set here. There's a ton of values and stuff like that. And in SPSS, actually, once the p-value gets really tiny, it doesn't like do any specific numbers. It just says it's less than 0.001, which we did have a less than 0.001. So going back here, what our kind of null hypothesis would be for this one sample t-test would be that um, there is no difference between this sample size of students, so all the students in this data set, and the accepted mean, so the mean of 3.01 or 3.0. Uh, and the alternative hypothesis would be that there is a difference between the two groups, meaning that meaning that the sample group's GPA is either less or more than the accepted mean. So for this one, as we have that the p-value is less than 0.001, meaning that it is less than 0.05, our significance, or the significance level that we pick and what is generally used in statistics, we can reject the null hypothesis and state that there is a pretty significant difference between the GPA of the students in the data set and the accepted the accepted GPA mean. So now we're going to be performing an independent t-test in SPSS. So with this one, we're going to be using the same data set that we had earlier, but instead of just using the GPA, we're going to be comparing it with tutoring. So we're going to be performing this test with GPA and tutoring sample data. We will use this test to see if tutoring had an effect on the GPA of the students compared to those that didn't tutor. So for this, our null hypothesis would be that there is no difference between students who tutored and didn't tutor in their GPAs. So it doesn't matter if you tutor or didn't tutor, your GPA will be the same. The alternative hypothesis would state that there is a difference between the two kind of the two the two groups, meaning that either tutoring or not tutoring either increased or decreased your GPA. So again, we go to the Analyze tab as the previous test. We'll choose the independent sample t-test data now, and as earlier, we'll be presented with this window. It's a little different from the other window because now we're going to be testing two different groups from the same data set. But our GPA will still go into the test variables, as that is kind of what we're testing against. But instead of what's it called? Instead of leaving it there, we now put tutoring into our grouping variable. So the grouping variable needs you to kind of define the groups that are going to be the two groups that you're testing against. So what this means is you're going to have the two groups, the non-tutored kids and the tutored kids, and the test variable is going to be the GPA of each of them. But you have to define the two different groups based on the data that you had in the, in your kind of SPSS data view data set. So for us, our groups are going to be 0 and 1 because we used 1 and 0 to signify tutored and not tutored. So whether this is a string or whether this is a, so let's say that you did T and N for tutored and not tutored, these are going to be the groups that you use, and you have to use the groups that are used in the data set itself, or else you'll get an error like I did many times trying to figure out what I did wrong. So then you press OK to perform the test itself and then get the results like we did earlier. So for this one, we get that the t-statistic is -7.170, degrees of freedom is 2,390, pretty much the same as we had earlier, and the p-value is less than 0.001, meaning that we can reject the null hypothesis and state that there is a significant difference between the means of students who got tutored and didn't get tutored. Okay. So now we're going to be performing a paired t-test. So to perform this test, we have, like our example that we stated before, the weight loss before and after a diet. We will test for if the diet had an effect on the mean of the weight. So again, go to the Analyze tab as the previous two tests, choose the paired samples t-test. This is the screen that you're going to be presented with. Not anything special really that you have to do for this. Just make sure that you choose the before variable first so that it's variable 1, and then choose the after variable second, so the pre-weight that we're using, and the post-weight, which is the weight 6 weeks after the diet. And actually, I forgot to state here that our null hypothesis will be that there is no difference between the two groups' weight, like between the means of the two groups' weight after the before and after the diet, and the alternative hypothesis is that there is going to be a significant difference. So you insert the information, press OK to perform the test and get the results. And so the t-statistic is 13.3. The degrees of freedom is 7, and the p-value is less than 0.001 once again, meaning that we reject the null hypothesis and state that the diet does have a difference on the mean weight of each of the groups. So that is pretty much it that I have for this lecture. I kind of did want to show you kind of in real time how you would perform one of these tests. So give me a second. I think it's this one. Alrighty, perfect. So you would want to just press the analyze, go to compare, independent, let's just do the one sample here. Just really quickly, just to show you that, yeah, our test variable is already in, test value is already in. Press OK. And then we'll have here in our output, you can tell that I did a ton of tests trying to test here. You'll have our one sample t-test right here. As you can see, it's the same as we had earlier. So that is pretty much it for my lecture. Thank you so much for watching. And thank you for taking the time to grade this. Goodbye.